Hello everyone, my name is Lyhour. I am a sophomore civil engineer student. Today I would like to share you an essential tool which is I find it very important for engineer, especially for civil engineer and structural engineer, which they involve with most of the trust and many kinds of member things. So by that, let me introduce you to PermaLearn. So let's get started. So to start, let's open our internet browser. So click on this and let's type permalearn.xyz. So here's our website, and in this website we are having many tabs. We have member tab, support, hinge, joint load, point load, linear distribute load, and many kind of more tabs options. So to start this app, first we have a grip site on this site. Let's say you have a bigger projects or bigger size of problem solving, so you can set it in this part. And mesh size is just like a pixel of a video, so if you make it smaller, it's giving you lots of value in one grips. And we also have a unit system as well in SI or BG, but for me I would use SI. So to have a good example of this website using, so let me bring you one of my exercise. So let's say I have one exercise which I have done it recently. They want us to determine the internal normal force and shear force and the moment at point C, which is right here. By this problem, they only have one member, which is member A and B, and they want to find the load, the force reacted in this point C. So let's get started. So our beginning coordinate, which is 0, 0, I assume it to be like that, and it's from A to B, which is 6 meters, so let's type 6 meters. And for the vertical distance is 0, there's no vertical distance, so let's add it. So here's our member, and let's say I accidentally press a vertical member upward. Let's say I press 4 at point A. Let's say I press 4, and by that you can also delete it. You can press on this, you can press delete or edit it, but for me I would press delete, which is much easier. And for this, we are done in the member tab. And going to the support tab, we have a point, a joint. Yeah, we have it as a pins. And for B, we have it as a roller. So I'll go through it quicker. And we also have a hinge, tabs, joint tabs, and point tabs. Let's just say joint tabs. I have a force which is act on a point. So let's say it is a vertical or horizontal. So if you set it to be a vertical, let's say I set it 5k newtons downward. So don't forget that the unit is in k newtons, so it's gonna be 5,000 newtons. So it's going downward. 5 neurons. Okay, so we got this minus 5k neurons. But in our problem, we don't need this, so we can delete it. So in our problem, we are using a linear distributed load, which is in our member from A to B, which is member ID1. So for the load type, it is a vertical load, and the distance from begin joint and end joint, is 0, and the begin load is 200 neurons per meter, but for this it should be minus 0.2, and another one is minus 0.4, and here's our load. So that's it for this. So we can go into the solution and we can check on the answer. So for the reaction force is related to the support reaction on the fixed and roller. So it's gonna be a 0.8 k neurons at AY of AY, and another one is BY, which is 1k neurons. So there's no AX, and we can also check the normal force. There's no normal force since there's no force act on horizontal, and we can check the shear force on point C, 0.05, just like what we did, and bending moment as well. So bending moment at point C is 1.35 k neurons, just like what we did in this exercise. So that's it for this tool, and I hope you like it. So that's it for my video, and thank you for your watching. Bye.